everybody. So my name is Sandrine. I joined Florian about a year and a half ago. And Florian so the talk might not be as inspirational as Chris. We are more in a commercial phase, so we are looking at actually trying to sell a product made from plants. You are really so inspiring because you've so further advanced in the making of it. So who we are? We are actually a company that comes from Sheffield University, so could be inspiring for you. So the technology was developed by Dr. Andrew Gill, who studied in Sheffield, and after his PhD, he did a KTP with an industrial company that was sponsoring the KTP. And from that KTP, then a forum was created 12 years ago. For the first 10 years of the company, it was really focused on developing the technology, filing the patent, making sure that it's protected, and making sure that what they were seeing in the lab was also applicable in real life industrial application. And by 2023, the company was really ready to launch commercially and secured some private equity funding, which enable us to create a team. So we are transitioning from an R&D innovation company with ideas to actually now having a real product selling to the market. So that's where we are today. We're only a small team. There's 6 of us, hopefully soon 7. We've relocated to Sheffield Technology Park, which is a nice hub with lots of startup in the tech industry. From my accent, probably you have guessed I'm not from Sheffield originally. I'm from France, but I have been working in the UK now for more than 20 years. But if there is anything that you don't understand with my accent, just stop me, no problem at all. So what do we do at Florian? So we start with PLA. So what is PLA? PLA is polylactic acid. So it's a polymer made from the sugar from plants. Most of the time, polylactic acid is based on a feedstock from corn. You have in the world you have 4 countries, really big producers of PLA. You have Thailand, China, the US, and there is a plant being built in France. And in France, interestingly, they're going to be using wheat instead of corn as the feedstock. So we take the sugar out of the plants, and with that sugar, we then polymerize it into a polylactic acid as they breathe. The producer of PLA produce the PLA, and where we add value. So PLA today, if you looked in your day-to-day, you will find PLA like plastic cutlery. You would find it in bin liner, coffee capsule. Typically, the application that are single-use and that are going to be composted, industrially composted. At the start of this project, the idea was that the industrial that sponsored the KTP with Sheffield University was selling product into offices. And rewind 12 years ago, in most offices, you would find a water fountain with a big bottle, a big polycarbonate bottle, which you would keep getting renewed bottle. Those bottles were made of polycarbonate. And the idea of this entrepreneur was, well, how about if I could have the same bottle but made out of a plant-based polymer? So that was the spark that created Florian. But since we've moved on and we've decided, well, actually, it's great, and the market already has many solutions in terms of using plant-based plastic for single-use application. But what if we could also use the plant-based, maintain the sustainability criteria, but really now bring it to the industrial application? Because we see a lot of program on TV saying plastic is bad, we need to ban plastic, but in reality, we can't ban plastic. There are some really good applications for plastic. It's lightweight. It helps protect food for a long period of time, so we are able to reduce food waste. We can't look at a problem in just a silo. We have to look at what else are we going to create as a problem if we ban completely plastic? So what we do is we take PLA and we enhance it. So this is where we have developed, the team has developed a portfolio of patents to enhance the performance of PLA to the level that is comparable to engineered polymer. And we talked about the word engineered. What does it mean, engineered? It means durable, high mechanical strength. It's for applications that are demanding, so automotive, rail, marine, electrical, electronic application, these type of application. And the flagship product for our company is called Floron Thermatech, and this is a polymer, plant-based, so 80% renewable content, very low carbon footprint, 7 times lower than the comparable engineered polymers. But on top of that, it's also flame retardant. So if you were to ignite the material, it would self-extinguish and it wouldn't rip. So it's very useful for application in the electrical appliances, these type of products. And today, typically, for those applications, if you take your laptop, the casing of the laptop would be made of a product called ABS. ABS is a plastic based from fossil, and here we're competing with a plant-based material. And also today in ABS, we would be using additive to give the fire property, which are based on halogenated material. Halogenated material are being phased out because of the environmental concern around them. So we were the first to develop an halogenated-free material that would still pass the demanding fire test um, and is plant-based. So all these really created quite a unique product, and I will show you later on some example of application. In terms of performance, if you look at the plant-based material, the Thermatech, against a market reference on the flame retardant ABS, you can see that we are comparable. I'm not going to go into the technical term of the UL94 V0. It might not be the right audience for that, but it is a standard recognized internationally, and it's about the fire safety of the material. So typical application, home appliances, anything that plugs in has to have fire resistant. That is a requirement, legal requirements. Laptop, computer, housing, power supply. You see a lot of products around this room that would require fire resistant, and also construction product. For example, intermess and seal under doors, and partition walls, especially in public building, needs to be fire retardant. So this is the fire resistant is the newest patent of the company. Before we managed to achieve the fire resistance, we already achieved the durability and the high strength with a product called Duratec. So it is equivalent to the Thermatec, but without the fire resistance. So, and again, we're competing in terms of performance against ABS, ABS. So similar tensile strengths, impact strengths, good at temperature stability, similar to ABS. And this, for example, would go into medical product, medical device. If you have an insulin pump, or if you are asthmatic and you have the spray, the inhaler, thank you. The inhaler would be made out of ABS, but now we have an option to make it out of a plant-based material. Toys, sporting goods, think about high impact strengths like safety helmets. If you go on your bike, those helmets have to have the high performance, and now it is possible without sacrificing the sustainability. Now, on those two applications, on the Thermatec and the Duratec, the end of life option, because this is very important. When a product is designed, we now have to think about how it's going to be disposed of. Because those, you want the durability, you want the material to be stable for as long as a fossil-based material. You don't want it to be breaking down sooner. So those are not biodegradable, and this is sometimes a problem we are facing in the consumer head. When we talk about plant-based polymer, automatically they are thinking, oh, it's going to be low performance and it's going to be biodegradable. It's not the case. Plant-based doesn't necessarily mean biodegradable. There are plant-based polymer, and we are one of them, that are durable and can achieve the long-term performance. And at the end of life for those two grades, sorry, so the end of life for those two grades is, have I done something wrong? Okay, not to worry. The end of life for the first two is recycling. But with the plant-based, we have two methods of recycling. We have mechanical recycling, where you break down the product, regrind it, and then remelt it without losing the performance. Or you have the additional option, which we don't have with fossil-based polymer, is chemical recycling. So we break it down and we go back to the monomer, we go back to the lactic acid. And even though we have flame retardant polymer, flame retardant additive in the Somatec, we are able to filter those out and still go back to the lactic acid monomer without any loss of performance. So much better end of life option than incineration. Biotech is the third product in the range. We missed a slide, but it doesn't matter. This one is more of your typical PLA application, but with extra high tensile strength. So this is used, for example, in the inside of a fridge. It replaces polystyrene, high impact polystyrene. So if you are material scientists, HIPS it's called. Very high impact, but on this one, we do have industrial compostability. And we are also working on developing a grade that will be home compostable. So industrial composting means it's done at 58 degrees C, whereas home composting is done, the test is done at 26, and you have to pass a certain number of days, ensure degradation against the control of at least 90%. So the application for biotech, which is the compostable grade, it's very varied. We have, so we can extrude a sheet, and then from the sheet we can thermoform, so it's more the typical packaging type. We can extrude fibers, and with the fiber we can make tea bags. There is a new regulation coming in place where tea bag has to be own compostable, so our technology fits very well in that. Um, the, so the material, what we supply, this is what we supply. So it's a granule, it's a pellet form, and then we supply to people who then transform these pellets into a product. And into a product could be a sheet, could be a fiber, could be a 3D print filament, or could be product that are injection molded. So it's a very versatile technology in terms of how it's being processed. And the beauty is that it fits within the existing manufacturing equipment of our customers. So we go in, all we have to do is change the temperature. They don't have to change the mold. It has similar shrinking rates to ABS. Advantages, low carbon footprint, 7 times lower than ABS, but also low temperature, low processing temperature, so we're reducing scope 2 and scope 3 emission. It's renewable, and it's also, the fourth point is the end of life option, which you don't always have with the fossil based material. Um, Iris mentioned, we were lucky enough to still be part of an Horizon EU-funded project. So the company is finishing this project, but in that project we were part of a consortium. So you have industrial partner, you have material partner, you have external laboratory doing the test. And in that project, we're looking at application in appliances, so fridge compartments, but also in automotive. So that black part here is it's part of a Fiat car, and this is a good way for us to prove the technology in a real environment, funded with the EU, and an excellent networking opportunity. Um, Other applications, so I brought with me. This is our very first commercial customer, and it's very interesting story because themselves they are a circular bioeconomy company. They they were selling office furniture, and they realized that in London, some of the big offices, they furnish the office just to sell the place. And then the office furniture never gets used and gets disposed of. It's a scandal, really. So they decided, well, how about if we had something that was more modular and that the new occupant wouldn't need to throw away what was there, but just dismantle it and then build what was needed for them. So they have, this is a Lego box, Lego block, but in a much bigger scale. And with those Lego blocks, sorry, you can create partition wall, you can create office furniture, think also about schools, think about exhibition. Every time you go to a new exhibition, you don't have to start, you just dismantle the bricks and build something that fits the size. And in a classroom, one year they might have more year six students, then and the next year it's the opposite, it's year seven where it's bigger classroom. So you just move the partition wall and you change the configuration of the room. So it's a product that is designed with the concept of not constantly renewing the materials. The end of life is either mechanical or chemical recycling. And prior to coming across our material, they were using recycled ABS. So that was already a step in the right direction by using recycled polymer. However, they needed the fire retardancy for the partition wall. And with recycled material, the challenge is the feedstock. You have a feedstock coming from different, you have consumer, you have industrial waste, and then that gets agglomerated together and then created a new polymer. And because of the inconsistency of the feedstock, there is more variability in the recycled polymer that you are buying. And to pass the very stringent fire regulation, it was not possible with a recycled material. Whereas a plant-based, you still have all the sustainable credential, but you also have the stable feedstock and you were able to pass it. And then a few other applications. I broke it. No. So 3D print filament, I showed you some example extrusion films. We are working with other bioplastic manufacturers where they might have a soluble film and they might need our material in a multi-layer system. The message I also want to share today is that there is going to be no one solution fit all. In finding a sustainable future, we all need to collaborate. Our material will be fit for certain application, and for other application there will be a better material. And it's about working together to achieve that future. And always keep that in mind, whatever you do in the future. Collaboratively, we're going to achieve far greater things than alone. And I think that's it. Yeah, thank you very much.
So, that was really interesting. So, have a think about any questions you want to ask Sandrine or anybody that's